Imagine building an empire at an altitude that would put most modern athletes into a hospital bed within hours. Not visiting, not surviving a few uncomfortable days, building roads, terraces, temples, and a functioning civilization of several million people permanently in air that holds roughly 40% less oxygen than it does at sea level. That was daily life for the Inca. And to understand how, you have to start in the former capital of their empire. You're standing at 3,400 meters above sea level in Cusco, the former capital of the Inca Empire, and the air around you contains roughly 40% less oxygen than it does at sea level. If you flew in from Lima yesterday, your heart is already beating faster than normal just sitting still. Your head has a dull, persistent ache, and walking up a single flight of stone steps leaves you genuinely breathless. Here's the reframe worth sitting with before anything else. The Inca weren't gritting their teeth through thin air the way a modern climber does on Everest. They had spent thousands of years, across generations that predate the Inca Empire itself, turning altitude from a constant physiological emergency into simply the baseline condition of being alive. And the story of exactly how that happened runs through human biology, agricultural engineering, and food science in ways most people have never had explained clearly. Start with the body itself, because this is where the story gets genuinely strange. Every high-altitude population on Earth had to solve the same core problem: not enough oxygen molecules per breath to keep tissues functioning normally, a condition called hypoxia. But different populations solved it in completely different, independently evolved ways. Tibetans, whose ancestors have lived on the high plateau for tens of thousands of years, evolved a variant of a gene called EPAS, one that actually keeps their hemoglobin levels relatively low and stable at altitude, prioritizing efficient oxygen use over raw blood oxygen capacity. Andean populations, descendants of the Aymara and Quechua peoples who built the foundations Inca civilization was raised on, took the opposite genetic path entirely. Research led by hematologist Ricardo Amaru and colleagues has found that Andean highlanders instead evolved to function with dramatically elevated hemoglobin concentrations, more oxygen-carrying red blood cells per liter of blood than almost any population on Earth, compensating for thin air with sheer blood oxygen capacity rather than metabolic efficiency. Two populations, two mountain ranges, two completely different genetic solutions to the identical problem, arrived at independently over thousands of years, neither one copying the other. And in a third case entirely, researchers studying Ethiopian highland populations found yet a different genetic pathway again, involving different genes entirely, converging on the same functional outcome through convergent evolution happening on three separate continents at once. That genetic baseline gave Andean populations, and by extension the Inca, a biological head start. But biology alone doesn't feed an empire, and this is where Inca ingenuity and food technology enters the story, centered on one specific, almost magical piece of engineering: chuño. The problem chuño solved was brutally practical. Potatoes, the primary Andean staple crop, rot within about a week in normal conditions, and fresh potatoes are heavy, awkward to transport across steep mountain terrain, and impossible to stockpile for lean years. So Andean farmers, working at altitudes above 3,500 meters, where nighttime temperatures regularly plunge below freezing even as daytime sun remains intense, developed a process that essentially freeze-dried potatoes centuries before anyone had a word for freeze-drying. Potatoes were laid out on the ground overnight, allowed to freeze solid in the brutal high-altitude cold, then thawed and trampled by foot the next morning to physically squeeze out the moisture that freezing had ruptured out of the cell walls. Repeat that freeze-thaw-trample cycle for several days, and the result is chuño, a lightweight, nearly indestructible dried potato that archaeologists have found can remain edible for over 20 years in storage, and that Inca administrators stockpiled by the ton in state storehouses called colchas, positioned across the empire, specifically as insurance against crop failure and famine. In 2026, Archaeologists excavating an Inca site on Peru's arid coast recovered 2 intact 500-year-old freeze-dried potatoes. Physical proof that this mountain-altitude food technology, something that can only be manufactured in freezing, high-elevation conditions, was being transported hundreds of kilometers down to sea level as part of a functioning empire-wide logistics network. That logistics network itself was a direct response to altitude, not despite it. The famous Inca road system, the Quipac Ñan, stretched across radically different elevations, and rather than fighting that variation, Inca administrators exploited it deliberately, building a system of relay runners called chasquis and storage depots positioned at different altitude zones specifically so that food, textiles, and goods produced in one climate band could be redistributed to populations living in another. A drought devastating crops in one valley didn't have to mean famine, because the empire's storage and transport system was explicitly engineered around the reality that altitude created dramatically different growing conditions within short physical distances. And that same altitude-driven variation showed up directly in Inca farming itself, most visibly in the terraces, called Andeans, still visible carved into mountainsides across Peru today. These weren't simply flat ground carved out of a slope for convenience. Each terrace level sat at a slightly different elevation, and even a difference of a few hundred meters in the Andes can shift average temperature, rainfall, and growing season length substantially. Inca agronomists effectively built a stack of distinct microclimates on a single mountainside, growing frost-hardy potato varieties on the highest, coldest terraces while cultivating maize, which needs warmer conditions, on lower terraces just a short walk away. Altitude, the same force making the air dangerously thin to breathe, became the exact mechanism that let a single hillside produce an entire diversified food supply. There was a chemical shortcut too, one that predates the Inca by thousands of years, but that the empire relied on heavily. Coca leaves, chewed slowly and mixed with a small amount of alkaline ash to release their active compounds, mildly suppress appetite, reduce the perception of fatigue, and appear to modestly ease some symptoms of altitude sickness, headache, and exhaustion in particular. Though modern research is clear, it doesn't meaningfully change actual blood oxygen saturation. For Inca laborers, messengers, and soldiers moving constantly across extreme elevation changes, a leaf that could be carried in a small pouch and chewed on the move was a lightweight, renewable tool against a problem that otherwise had no immediate remedy. Now here's the turn. Altitude wasn't purely a problem the Inca solved around. It also actively protected them, for a while, from one of the deadliest forces in their history. When Spanish conquistadors arrived in the 1530s, they came from sea level, and many of their soldiers and horses struggled badly with the thin air the moment fighting moved into the highlands, suffering exactly the breathlessness, exhaustion, and impaired judgment that any unacclimatized lowlander experiences at extreme elevation. Cusco itself, and especially the mountain citadel of Machu Picchu, built at over 2,400 meters on a ridge accessible only by narrow paths, functioned as a natural fortress that punished outsiders simply for showing up. It wasn't a wall anyone built. It was a few thousand meters of elevation gain that a genetically adapted, chuño-fed, coca-chewing population could handle without a second thought, and that an invading army from sea level physically could not match no matter how well armed they were. Machu Picchu's altitude and remoteness are also part of why it survived largely intact and hidden from colonial destruction for centuries. Rediscovered by the outside world only in 1911, while lower altitude Inca sites accessible to Spanish colonizers were far more thoroughly looted and dismantled. The same elevation that made daily life a physiological negotiation also quietly protected an entire architectural record of the empire from the fate that befell so much of the rest of it. So when you put the whole picture together, a population that had genetically rewired its own blood chemistry over thousands of years, a food technology that turned lethal nighttime freezing into a preservation method, a road and storage network explicitly built around exploiting elevation differences rather than ignoring them, terraces that stacked multiple climates onto a single hillside, and a mountain fortress that made altitude itself a weapon against invasion, the thin air stopped being simply a hazard the Inca endured. It became one of the load-bearing structures the entire civilization was built on. Today, a tourist landing in Cusco reaches for an oxygen canister sold at the airport gift shop, sips coca tea in a hotel lobby, and complains about the headache for 2 days before their body starts adjusting. That tourist is running the exact same physiological process an unacclimatized Spanish soldier ran 500 years ago, arriving at a place that had already spent millennia turning what nearly killed outsiders into simply what it meant to live there.